Okay, thank you. We do not need your volume to be 100%. Whoever was in here was playing. All right, start video. Wrong camera.
How you? Wow. Hey, Stephen.
There's Art. Everybody say hi, Art.
Hi, Art.
Our volume on our TV was 99%. It was
Oh.
very, very loud. I turned it down. Now I can't hear Art. Say
You can't
something.
hear me because I'm not talking.
Oh, there you go. All right. I hear you. Dun, dun, dun. Notice I didn't bring all the blocks today. So I made some changes to how this thing actually works. And let's see here.
Okay.
Can't really tell.
More center.
The LEDs are actually different. They're actually in the right order now. So over here on this side, that's the neurons firing. And on this side, that's the inputs. So there's two inputs and it's in training mode right now. So it's firing, trying to learn what it's supposed to learn. And I changed the training data for it. In the training data, it now takes a lot longer for it to learn. That's why I turned it on so early.
So what does it learn? It learns the shape of the table and the obstacles, or what?
Well, so the two inputs are the ultrasonics.
Right?
So it's learning distances. It's learning the training data is distances. So the actual output is going to be kind of a shallow left turn, a shallow right turn, a hard left turn, a hard right turn, or go straight. So that's what it's doing right now, is trying to figure out, you know, if I get this number and this number, should I go left? Or if I get this number and this number, should I go right? Or if I get this number and this number, should I go straight? So
it has to relearn that each time you change a place where it's working?
no, actually, it has to relearn that because that's the way the program's written. It doesn't save its trained information. That's going to be something that I kind of want to add to it, is so that it saves it in to an SD card or something, so it could just reload it and be a lot faster. But right now, when you kill the power, it forgets everything it ever knew.
And like me every morning.
Every morning, I forget everything I
You
ever
see.
knew.
Sounds like Groundhog Day.
Yeah,
I smell pine.
it, I forget exactly. I think it goes through 2,000 training cycles. And if there's 2 error codes, and if the error codes aren't below a certain value, then it starts to retrain again to try to get those error codes down to the closest to that value that it can get.
So what is it learning right now? Just how sensitive the ultrasonics are?
Right now, there's just a batch of numbers that it's being told. So it's cycling through those, and it's trying to come out and predict, if it sees this number. So the training data is 2 parts. There's the numbers that are the input numbers, and then the expected output value. So
Okay.
if we want it to go straight, say, 120 centimeters on both, we'll tell it to go straight.
Mhm.
So what it's doing is it's running through this training data, and as it's doing it, it's trying to predict that, I see 120, so I'm going to predict that means turn left. Well, that's wrong. It should predict that it's turning right. So it's trying to get, or going straight, not turning right. So as it's running through, as it's cycling through this training data, it's trying to predict what it should do.
Okay.
And once it gets to a spot where its predictions are more correct than are incorrect, it will start going. And basically it's the humans have said, we want your predictions to be 0.04% correct or
False.
false. The opposite of correct. So it's running through, I mean, there's really only 25 sets of numbers that it's running through, but it's running through that thousands of times to get it trained up. I mean, there's actually like
Without any changes to its input, how does it?
well, once it decides that it's trained, that it actually can predict what it needs to do, then it will start using the ultrasonics.
Okay.
And then it will say, okay, this ultrasonics is saying 33 and this ultrasonic is saying 100. I can take an educated guess that I need to turn one direction or the other. That's what it's trying to do, but it doesn't actually know that it's turning. It just knows that, this neuron is going to cause an action to cause it to turn.
So in theory, you could swap the motor leads so that left is right and right is left, and it should figure that out.
When I first did this, because I misunderstood what the original program was doing, I had the hard turn and the soft turn inverted swap. And while it worked, it was funky. So having the proper order of what those neurons are actually supposed to do does actually help. But yeah, I mean, in theory, I'll show a video of it. You'll see where it gets itself into a corner and just starts bouncing around because it really doesn't know. And eventually it decides, okay, I'm just going to flip 180 degrees and go the other direction. And how it decided to do that, I have no idea. There's a lot of weird magic happening in here that I only understand probably about a third of what's actually going on in here. Especially when it comes to how it's actually being trained. There's a lot of weird, funky math that I'm sitting there going, I know math and I don't understand
I
this.
did do that.
I don't understand what, oh, look.
It has no edge detection.
It does not. So I don't know if you saw the original. The original never backed up.
Yeah, okay. No, I didn't.
Mine, because it's just a little more funky. I love how it can detect
Yeah.
right off the edge. It's seeing a lot of stuff. Who pointed that direction? Hey, go that direction. Oh, you're seeing chairs, aren't you? I bet. You're seeing chairs. You're seeing Steve. We're going to see Steve.
That's why I'm screaming. Ah! It is seeing it. That's good. Man, that's amazing, Leroy.
It's a lot better now than it was.
Oh, yeah. What's that? It's working.
Finding the right numbers to get it to train on seems to be the tricky part at this point.
So Leroy,
Yes.
you said there were 5 different situations:
Right.
hard right, not so hard right, straight ahead, hard left, not so hard left. Where does it get the command to back up?
Fear.
Fear. That's exactly I had it in the kitchen and it was driving around and it was backing up. And Patty said, it looks like it's scared. I said, yeah. It doesn't know the difference. I mean, so
It needs one more response.
yeah,
I'm trapped, screw it, I'll just.
I think so too. I think it needs like just a dead stop kind of deal.
And now it just lost everything.
It just lost everything. All that training, gone. So the original code had it always moving forward. My initially I had it on a table, 6 foot by 2 foot table. And those boxes surrounding it. Well, I found that it needs a much wider open space. That's why I didn't bring the boxes today. But when it was on that table, I made the decision to go ahead and have it back up instead of always trying to go forward and make a turn. Because on that table, it was much too small and it was always saying a box when it was trying to turn. That was also when I also had it, the hard left and the soft left inverted in the first place. And I didn't realize that until I put it down into a wider area, that the two were actually inverted. So that's why it's backing up though, Art, because I made that decision. That was a decision I made. And I think for this particular robot, it works kind of well to have it back up a little.
Well, so you need a bigger table simply because it doesn't respond quickly enough, or you need a bigger table. I don't understand why it doesn't work on a small table if it works on a big table.
Or a wider open space.
Yeah.
I think it has more to do with Okay.
sensitivity of the ultrasonics.
A little bit of that. But the original project, I mean, that robot was probably that big and probably that tall. So
Okay.
it was I mean, this thing's half a foot. The original project probably was 1.5 feet. Much bigger, and it was also a tracked robot, which makes a
Slows it down
a little bit of difference, but not a huge amount. But I think because I was originally using the original training data because I just wanted to get something working. His robot was bigger, and you'll even see in my video that I show where it doesn't always go forward when you would think, okay, that's an open area, it should go forward. But I think that's because he had his set for 150 because he's another foot longer than mine. Where if I set it for like, when I started making some changes to the ultrasonics and how it worked, I started playing with that. The go forward part in particular was where I started to see a lot of changes, and that's where I started changing a lot of the code was for go forward. And I think it works better now, but I don't think it's perfect. And I think it's all because I need to figure out, that's 300. Well, he had it at about half of that.
So are you able to control the speed?
Yes, I can control. Yes and no. It's kind of funky how the original robot was obviously able to read the battery power, but in the code he never enabled how to read the battery power. So he was making changes based on battery. It looked like he probably was going to add
find a home base.
a battery. No, not that. It was more as the battery starts to diminish, the wheels will start to turn slower. So you increase the speed
Okay,
to maintain.
those are survey, the continuous rotation survey.
No, that's right.
Oh, well, these things, okay.
But it looked to me like he had planned to add the ability for it to make speed changes, but never actually implemented it. And in my particular design, I just got rid of all that because I can't read the battery voltage anyway, and it didn't look like it was being used. So that's technically, if I could do something, like, well, it's kind of hard because I don't fully understand where the training or how the training data works. I've got a grasp of it, but you could, I think you could add a couple more neurons where it was like,
It's Ray.
if it's 200 centimeters away from something, it could go faster until it got closer. I think that's possible to do.
Well, I was wondering if you could just slow it down and essentially scale down the size of an open area you needed by slowing down the motors.
I probably could make it go a little bit slower. It's already, it's
are these-
already pretty slow.
Are these brushless DC?
They would,
I would say they're brushed. They're the
Cute little things.
little tiny suckers. They're like vibration motors. A little bit bigger than that, but they are gear motored. You can see the gears on them.
Okay. No, it may
Brush
be
DC.
difficult to slow those down.
It's, they will definitely go faster. I've already got it going. I've already got it slowed down. Not so sure how much further slow they could go. But it's all driven by PWM, so I mean it wouldn't take much to figure it.
Oh, okay.
Yeah.
Well, then what's going to happen is if you try to slow it down, you're going to drop torque as well. So they
If you
may
keep
not.
PWM, they'll keep the torque.
Okay.
Yeah, this one, I'm not even sure what motor driver it actually is using. This one, it's interesting because you said it's only got two control pins. One of them is a PWM pin and one of them is a direction pin. So that's how you control this one, which definitely was a change from those whatever those are, 298s that we're used to using.
Yeah, those are audio amplifiers. They're not motor drivers.
I do have, dun, dun, dun. Let's see if I can pull this up. I will fix this.
So you got a video?
I do. If I can figure it out. Like this.
Make sure everyone can share videos. Yeah.
That is not the channel I want. Okay.
You can't do it just by sharing the screen?
I will. I just gotta log into YouTube because
Oh, so you've got it on YouTube then?
yeah. But I don't have it on I don't have it on our YouTube. I have it on my YouTube. So I gotta fix that. No. Oh, that won't work. What am I doing? Do this. We probably don't need to hear it. I can turn off the hearing. Then pause. And then we go to share the screen. And go like that. Everybody see it in full screen?
Yep.
Yeah.
All right. I did it right. It's playing annoying music, so you don't need to hear the annoying music.
This is yours or this is his?
Nope, this is mine. This is my kitchen. The only room that doesn't have carpet where it would actually roll. This was still using his training data without any kind of corrections to make it go forward or anything else.
Oh, that's right. Wait, ni hao. Oh, guess not.
It's working. Yeah.
kind of doing the same thing it was doing on the table. I think it works a little bit better off.
Yeah, it's doing fine.
Yeah, I was pretty happy with it. There, if you watch it'll roll off to the left a bit. There's no kind of correction on the one motor's a little bit slower. I fixed that. I put a correction in it so that I could fix them. But it'll get up here in this corner. And you'll see it does stuff like that, and then suddenly it just decides to turn around.
Looking for a place to go. Yeah.
See, there's nothing really around it when it decided to turn around like that. I was like,
Let's see, there's something in front of it now. It's got to turn. Yeah.
yeah,
It's making very good decisions, I think. See, there's something coming, so he's gonna turn.
but I really like how it's catching it off of the side, because the ultrasonics are horrible about catching the side of something. So that's the progress. That's my update.
Okay, looking good.
Yep. Real progress.
I think it's progress. It's something. I spent a lot of time messing with why the LEDs don't work. The LEDs should be working while it's driving around. I have no idea why they're not working. And I'm getting to the point where I honestly am starting not to care. But it's really cool. The original, as his is driving around, you can see the neurons firing on his LED
Hello?
thing. You're getting muted, Ray. So Ray can talk all he wants, but he's muted. You can unmute. It was only because you were answering the phone, Ray. We got a new message. Uh-oh. Uh-oh. What kind of thing did Ray say?
Hello to y'all. He's a Southern guy.
Still
Unmuted, but I still have nothing to say, so.
Uh, yeah.
Steve over there, he, I don't know if he tricked me into buying a server or he twisted my arm to buy a server or. And then it was like, no, Ray, you don't need one, you need two. And we've got more, so maybe you can buy 3 more next week.
Why buy one when you could buy 7?
So you can
How-
get you
how
a good
is,
deal on blades.
How was Hamvention?
For me, Handventure
Yeah.
was pretty good.
Yeah. I don't,
Great.
did we talk after Hamvention? I don't know if we did.
I don't think so. I did buy some patch panels for Keystone 110 style. Got a whole bunch of keystones to fit in there. A whole bunch of patch cables. Several hundred feet of shielded Cat 6 for going outside. I got to put some more network cable from building to building. My front warehouse is almost ready to rent. We've been painting and doing stuff inside. So I've been trying to make sure that my network rack panel there is ready to go. Because one of the things I do for my warehouse tenants is that I make sure that there's something of a network there, whether it's wireless or whatever. But this is a pretty intense, nice building. So we put in 24 wired locations and 24 phone jacks that also go to the patch panel. We also have Ubiquity wireless on a UAP AC Pro. And we're gonna have some other nice things for them in the patch panel and the rack. Just it's ready for them to decide if they want to put in cameras, if they want to put in a mini server or something like that. So at least I know what can fit in there. If they want to put in a QNAP, which is something I do recommend for everybody. But it's just simple network storage space that most companies don't think about. But to have a building pre-wired, ready to go, I think it's pretty alluring. So I've been doing that. And while I was at the Hamvention, I also found a bunch of these really small 24-volt DIN mountable power supplies. I was like, oh, good. I want to go ahead and buy these. But they were already wired to a 12-volt power supply, which I really didn't care about. And then they were wired to an adapter that goes from camera audio video input to Ethernet IP. So you plug in your audio video into this thing, and I guess it hosts a website. I haven't done the research to find out what this little thing is, but I bought the 24-volt power supply, the 12-volt power supply, the Ethernet adapter, a camera, and a hard surface microphone, all for $12. I thought, wait, this is great. I love these. I might as well go buy 12 sets. So I bought several sets of these things. And the only thing I really wanted out of it was the power supplies. I really don't care for the rest of the stuff, because to me, those power supplies are worth the $12. And I was going to see if one of you guys, anybody wanted the camera or the IP stuff, the adapter. Maybe if you're taking an older high-res camera and wanted to make it Ethernet capable.
You said there were DIN rails?
The power supplies are DIN rail mountable.
Oh, you
So
didn't
it
get
means
any,
that they clip into the
no.
equipment easier, faster. So I don't have to actually screw them to the back panel. That way I can put something in, play with it, and if I don't like
Take
it,
it
I
out,
can
yeah.
take it out.
But you didn't get any DIN rails out of the deal.
I have lots and lots of DIN rail here.
Oh, okay.
Yeah, I had a couple 100 feet of 2 different styles of DIN rail. A lot of our laser equipment, either stuff is mounted in permanent, obviously the way it normally is, or there's like relays, contactors, and stuff like that that are on a DIN rail. And sometimes the factory gives us an extra 2 or 3 inches of DIN rail, and it gives us space to add more relays or power supply or something else. So it's a good thing for us.
What do the Ethernet things for the cameras look like?
The little adapters are maybe twice the size of a deck of cards.
Okay.
And on one side, they've got power going in and out and a jack. And on the other side, they've got the audio video going in. I think they've got a sticker on them that says what the IP address is. I've been meaning to play with them at home, but I just have so much to do.
Thought maybe they were just adapters to run. So you ran the Cat5 instead of running 3 wires, you run Cat5.
No.
They were not PoE injectors or anything like that. They're strictly for.
Yeah, that's what those are, balance.
Yeah, like I would have a camera in, like, say, out in the warehouse, and I would give it 110 volts at the warehouse, and it would power up these little power supplies. But then in order to get that video back to the server, all I would need is a Cat5 cable. So
Okay. That's kind of interesting. Actually, it is kind of interesting. So you could stake and an old camera and stick it on a robot. Have that Cat5 run into a wireless router.
sure.
Connect to an AP and watch the video off the robot from it.
Sure, why not? And that
That
way you
might
could have
not work.
old equipment doing it.
And you could use really old stuff doing it.
What kind of microphones are they? You said hard surface microphones. Are they the
Yeah,
same?
I was kind of surprised. So what it is, it's a piece of like dense rubber, about 5 inches by 5 inches. And in the middle of it, there's a pickup microphone. So I guess they were mounting them to windows or something like that. But he actually said they are microphones to pick up audio. So if you talk, it's not just vibration or glass breakage, but they actually pick up sound.
Huh,
I thought,
cool.
okay, I'll play with that. I don't mind. So maybe next week or something, I'll have some kind of results with, what they do, what they are, or, how big a box I needed to throw them all in the garbage. So I don't know.
I'm sure somebody can find useful. Some part of that. They probably don't need a bunch.
So you can start reading.
Did I miss anything else before I came in here?
Just this little robot was rolling around.
I picked up most of that.
Yeah, you got here like right at the end where it was rolling on the table. It's in its training cycle right now, and it has been for a while. So that probably tells me that it has failed and is restarted.
Is that something you built out of a kit completely on its own, or like an add-on to another base?
Yeah, it's a hodgepodge. So the chassis is an adept starry bit for the microbit, like that one robot that you got.
Embed, yeah.
This here, the controller is a Banana Pi bit, which is an ESP32 based compatible, loosely compatible microbit replacement. The ultrasonics obviously are add-ons. They're 3.3 volt ultrasonics, which works great when you've only got a robot that has a 3 volt Gilly Bob, because most ultrasonics, as you know, are 5 volts, and they need that 5 volts. So these I bought these from Adafruit for $5 a piece, which was $4 more than the cheap ultrasonics, but it works. The little mount thing, I found that on Thingiverse, printed it. I had to print, a extra little deal there and figure out how to attach it because there's no real mounting points, and it's slightly cockeyed, and I think that causes a small inconsistency because the ultrasonic should actually be, but I think we could overlook the small inconsistencies.
Are they cockeyed inward or outward?
They're actually supposed to be straight, but they did kind of bow in just a little. In the code, there is, I did actually finally put a delay in so that it reads one, and then there's a small, teeny tiny delay before it reads the second.
That way you don't get crosstalk.
I tried to eliminate it. I also added an average to it, so it's only averaging out 10 pulses, but it does
You're doing a good
actually
job.
average, it does actually average it, and it does actually kind of center it. And why are we going backwards?
Because it sees everything everywhere and it wants to get away.
Maybe its battery is finally out.
Yeah, that's weird. I had a weird issue with this. There it goes. I had a weird issue with it. A couple of days ago, I was programming it, and it seemed like there was a small power surge, and one of the ultrasonics stopped working.
It's scared.
It's scared. I got you, Mark.
It figured it out. It's
Oh, go get on that wire,
You couldn't see it backed into the wire.
I mean, I think the most impressive thing about this though is that it actually can catch it off the side. Pretty good. Stop working. That motor stopped working again. It's almost like it. Oh,
Hello.
Vicente, are you doing any new projects lately?
well, Vicente's always doing projects.
Do you know the standard to communicate all computers with cassette interfaces with cassette recorders to transfer data? I was working on that for an emulator of an old computer, trying to reproduce the interface for the cassette. I'm working here with an Arduino Nano and a voice recorder.
Yeah, let me highlight your screen there, Vicente. Hang on. There you go.
Yeah, you see.
Okay, so that's the voice recorder, and you've got
This is the voice recorder with the file. The file is a 6 KB basic program. It's a Star Trek of 1976, a Star Trek program game,
yeah.
and I'm loading it in the using this Arduino, but the original circuit use a voltage comparator, and I am using the comparator inside the Arduino. Also, the original circuit use a monostable flip-flop timer, and I'm simulating the monostable timer with a Arduino timer, so I can record I can load the program. Let me connect it. Okay. Star Trek. Let me check.
Is it transferring music or is it transferring a like a video game program?
Is the program is encoding the ASCII characters using two frequencies, like FASK modulation. So you have the program in an MP3 file.
So it's it's digital data encoded in FSK.
Yeah,
Okay.
and I have the
Recorded on an audio recorder.
I think it's to do with your Zoom.
I download the file from a YouTube video, the file of the audio file. There is a YouTube video where they put the sound of the program, so I couldn't recover the program. Let me check something. The baud rate is 300 bauds. I don't know if this. And let me see.
How long is it?
5 minutes.
That's a lot of code.
The
That's
good
a
old,
lot.
the good old days of cassette loading.
Yes, it's very.
Yes, sir.
And you can see the program is loading. The basic program. This information is in the audio file. And I'm loading the program.
It's a long way to get to 690.
Excuse me?
300 baud.
I would have thought it was a higher speed than that.
You gotta,
This is part of a bigger project. I'm trying to emulate a computer from 1976. So this is the last part. Everything is almost ready. I have a CEDA-80 simulator inside the microcontroller. It's another microcontroller. It's not the Arduino Nano. It's a ATmega 1284 that has 128K flash memory. So it's enough space to have a CEDA-80 emulator inside. It's running at 2/3 of the full speed of the CEDA-80. The original system was 2 megahertz. So this thing is running 1.4, 1.3 megahertz, the simulation.
I'm curious, over here in your circuit board, you've got a bunch of blue resistors, some 2 diodes, some capacitors. Is that
Yeah.
a bandpass filter?
No, it's a limiter. The 2 diodes limit the voltage from the recorder.
Yeah.
To go inside the Arduino. I have the circuit here. Let me.
So there's Zener diodes or what? Gallium.
No, just signal diodes. One and 1848. I think is the most common one.
So what's the voltage on the Zeners?
No, there are no Zeners, just diodes.
Yeah, no.
Maximum
The
voltage.
Zener diodes have a cutoff voltage. What's the cutoff voltage on the Zener?
They're not.
There are no Zener. Those are diodes, normal diodes.
Oh, normal diodes.
Yeah.
Okay.
Let me look for the schematic. Mm. What I did, let me check here. Just a second.
Looks like he's got them set up as a bridge, so everything becomes a positive voltage, I guess. Doesn't have to worry about AC.
He's probably clamping the maximum voltage. They would fire at 0.7 volts, so the volt, and he puts a
Okay,
resistor
let
in
me
stereo.
share.
To clamp the voltage. And a pot coming off the backside. So your voltage is only gonna be this voltage max.
This is the circuit. You see the couple of diodes here limiting the voltage.
Mm-hmm.
This is the Arduino is
This clamping
this one here.
0.7.
The original circuit has a hysteresis circuit in the comparator, and because there is no way to feedback the signal of the comparator in your circuit, I am using the internal pull-up resistor of the Arduino to modify the level of the comparator and produce the hysteresis. Okay. Let me show you the signal. This is the magenta signal is the comparator level. I'm changing the level using the pull-up resistor, the internal pull-up resistor of the pin. I'm just changing the level to produce the hysteresis. Okay. The original circuit has a monostable circuit. I am using an internal timer of the Arduino to produce this monostable pulse. And depending on the frequency of the signal, I am using the monostable to copy the value of the comparator in the output, producing this signal here in green. That is the asynchronous communication, the serial communication at 300 baud. This is the original circuit of the computer. You see, it has a comparator with a feedback to produce the hysteresis. And this is a monostable circuit to produce the pulses to capture the value of the comparator. And here you have the signal, the asynchronous communication signal at 300 bauds. This circuit is only checking if the frequency is 2,400 hertz, the signal goes up, and if it's different, goes down. So the original sound will be converted in a digital signal. That's what I'm doing with the Arduino. This is the YouTube page where the program is. So I made this circuit to download the program in BASIC. You see, this is only a proof of concept to be added to my simulator. But the simulation will be real. I mean, you can connect a real cassette recorder and save your programs or load programs on the simulator. It's not a simulator, it's an emulator. That's it.
Cool.
I need to make all the assembly in a breadboard to put all together and validate all the stuff, but the CETA-80 simulator is running. All the hardware, I am simulating all the hardware in the board, the CTC, the timer for CETA-80. CTC, CETA-80 PO is an IO port chip. It's also simulated. So the final result will be, let me look for an image that show what it is. This is my idea. Let me share again the screen. Okay, this is the original board. Is this big one here? You see my mouse moving?
Mm-hmm.
Yep.
Okay. The idea was to use an 80 mega. Is here, the 80 mega is this chip. And inside the 80 mega will be a simulator for the CETA-80, the CETA-80 PO, IO ports, and the CETA-80 CTC is this one. So the RAM is inside the 80 mega. All the keyboard will be the same. The display will be the same one. And all the address and all the access will be exactly the same. So any program that runs in this board will run in this emulator. You see. An additional thing that is that you won't lose your program because the RAM is baked with a battery, so you can turn off your board and the program is still there. And this is the cassette interface here. I didn't put it in this drawing, but the connector will be here in the same area for the cassette interface. And here will be two 8-bit ports and one channel of the CTC for your experiments, for experimenting. That's the idea. You also will have a assembler and disassembler in a serial port, USB serial port, but this will be an add-on to this board. This board doesn't have communications, but I will put power and communications using this module here. That's it. I start using Arduino Mega for the first test. I was using an Arduino Mega, but I changed the Mega for this chip that has the same, almost the same capability. You have 4 8-bit ports, and you have half of the memory of the flash memory of the Arduino Mega. Instead of 256, you have 128 K flash. So you have a lot of memory, 16K memory, RAM, and you have 4K of EEPROM. So you have in this chip almost all you need for the simulation of the system. I don't have enough pinouts to control all the keyboard and display. So I added a microchip expander that will do the job of the CIDA-80 PIO. So this is what I was doing about this.
All his breadboards. Mine look like that.
That's it.
Very cool. I have a question for everybody. It's not related to any of this. I need about 20 IO points, digital IO points, that I can read with a Raspberry Pi. I would prefer that they be optically isolated, just for random stuff around the house. The water detector in the basement, is the garage door up or down? I've got 10,000 feet of old 4-conductor phone wire that I can hook up to switches and whatnot. I don't need to detect any voltages. I would kind of appreciate a thermocouple interface, but I've already got 12 points that I need, and I'm sure more will come up. So any ideas on about a 20-point IO card that can talk relatively gracefully to a Pi?
Well, you can use an Arduino Mega with a shield, and you connect it to your Arduino, to your Raspberry Pi using I2C.
Okay.
So you design some commands to send a status or to ask for status, and that's it. I think it can be done. I don't know.
Well, I was already at the point of it can be done.
I think there is a hat for the Raspberry Pi to read I/O. I don't know. Let me check. How many points?
I figure about 20. One thing I had been looking up was ST Microelectronics has a GPIO expander, and that's surprisingly expensive. And not isolated.
You need to isolate all the inputs, right?
I don't really need to, I don't think, but I've dealt with IO before that wasn't, and proves that it turns out that having it isolated is awful helpful. It also slows it down, gives you some hysteresis to deal with. So AC doesn't become a noise problem as much.
And will be easier to use a standard I/O for the Raspberry Pi and use 2 Raspberry Pis, maybe each one with a dozen of IOs or something.
What kind of voltage you gonna have out of these sensors, Steve?
Just switches mostly. I'll have switches on the end. I can run them on 3.3 volts, 5 volts, 12.
Oh, okay.
But
So they're strictly switch devices. So whatever voltage you provide to them, they respond to. Okay.
I just want to know if the circuit's open or closed.
Yeah, but in any case, you need to auto-isolate these long lines in your house from the Raspberry Pi.
Right.
In any case, you use another voltage, another power supply, using up to coppers in your interface board to be sure that any spike or induction in your lines in the house won't destroy your Raspberry Pi, you know?
Yeah, I found some fairly reasonable expanders, but none of them say they're optical.
Yeah.
Mm,
And at one point, I had probably 30 Opto 22 boards totally loaded with IO stuff, but I have no idea where those went.
I'm searching. There is an 8-channel,
Yeah.
8-channel for Raspberry Pi, but maybe not enough.
32
16.
channel.
16 opto-isolated for Raspberry Pi.
Thirty-two digital inputs controlled Raspberry Pi. External 5-volt with isolation solder jumper.
Okay.
It's probably about, I don't know. I don't know. It's probably going to cost more to have it shipped than it would what it is in the UK. It's 15 pounds in the UK.
I got 50,000 stuff I can send.
That's probably what, 15 pounds, $22 or something like that. It probably costs more to have it shipped.
That's cool.
It's the closest I've seen, but I don't think that's exactly what you want either.
Well, I got a box of those little 4-pin Opto chips, so man.
It's not an industrial application. You can probably get by without that.
Yeah, but if you're going to go, noise could show up on that line, especially if you're going to go any kind of distance.
Put 100 ohm resistor.
Raspberry Pi
Good
is,
Lord, you have 29 tabs open in your.
oh, you should see my wife's. She's got like 300 tabs
On her phone?
on her phone. Why
Can
is
I-
my phone so slow?
Can you share this with me?
Yeah,
Or
I'll
AV electronics stuff.
I will. I'll just text it to you. Or something. Maybe that's what I'll do.
What is those DC 3.3 volt, 5-volt driver? Is that either or?
Yeah, probably.
This is a voltage.
Oh, so you can put either 3.5 or 5 on the power supply. Okay.
I saw that one.
8 channels.
There's another one on Amazon too that was just a tiny bit cheaper, but I don't think it was optical isolated.
This is basically 24 volts to 5 volts. Mm.
Steve, have you looked at using Opto 22 modules?
Yeah, those are about $15 a channel though.
I'll give them to you.
I don't know what one it is.
He just needs some tech support. He's got plenty of stuff.
Leroy, be quiet.
I think this one is not isolated.
Do you
Yes.
have the boards that the Opto 22 modules go in?
Yes, I do.
That's the one I saw. I didn't see that it said that it was optically isolated. That looks like it's just a terminal board,
Yeah,
changing
So-
the IO to the terminal.
yeah, but
So what I'm thinking you could do, Steve, is that you could take the GPIO off of any networked microcontroller, whether it's an Arduino or it's a Raspberry Pi, and you can mount the IO unit anywhere in your house. And that way you can do the IO there locally. You can
Okay,
mount
yeah,
another
yeah.
unit, another part of your house. You can collect it all on your network.
Better, less cables.
Yeah.
Yeah.
I'm interested in the Opto 22s if you've got a pile of them.
I got a pile of it. If I don't have enough of it, I'll buy some for you.
I'll trade you around for it.
Because Leroy knows that I need the tech support later.
I started
I'm
putting
just saying.
together a care package for you today at work.
I appreciate that. That's why I'm like, if you need something, let me find it.
Okay.
I was thinking about doing a Halloween deal with me and my son. We were going to do a Raspberry Pi or at Mega, where we could do outputs on some channels, inputs on some other channels, just to build a Halloween scene. But he's nowhere near the right age to build that with me and have fun. I mean, he'd love to see it when it's done, but he's just not at the building level yet. So I have a bunch of Opto 22 stuff ready to give away. And how many units do you need? How many points?
I know 12 channels right now, 12 points, but I'm sure more will pop up. So I was hoping for 20.
Oh yeah, I think each Opto is a quad pack. So you can do AC input, AC output, DC input, DC output, and there are high speed and standard speed units.
Right.
And you can mix and match them all on the same board, and then they're readable through a 0 to 5 volt signaling that's on the end of the board.
Yeah, I've used them actually.
Oh, okay, well, I'm not teaching you anything. I'll be happy to donate a board or two for you because they got plenty of IO points on them.
Okay.
Some of the boards have a built-on power supply and a ribbon cable, so you can take the ribbon cable over to your Mega or Raspberry Pi GPIO.
Okay, cool. Thank you.
Let me see if I can quickly find the boards online of what I've got. I think 3 or 4 different styles.
That's just somewhere else to look.
Yeah, the ones I've got are an Opto 22 IDC5BQ, and those are $108 per pack. I'll give you a dozen packs or so if you want them. Brand new, they were $108. There's some that says used on eBay for like $2.43.
There you go. That's.
But there's also, I think the average price on there is about $80, $90. I don't know who the hell's selling them for $2.43. But
They fell off the back of truck.
yeah, well, there's a PB24HQ. And I'm guessing that that's 6 quad packs, which is total 24 IO points. And that's got a ribbon cable on it. Oh gosh, I've got a few of these different boards. Some of them smaller, some of them bigger, but that's back when I was I was doing surplus electronics, and I just ran into all kinds of this Opto 22 stuff, and I didn't want to see them go to the garbage, so I just started picking them up and keeping them. So I've got a drawer full of it at home, and probably 5 or 8, 10 boards, and just stacks of the Opto 22 modules.
Is it storming there, Ray?
It is raining. That's why I ran out. I wanted to make sure my windows were up.
Yeah, my doorbell camera just went off with a lightning strike. That's what that is.
David, I'm in a meeting. Let me call you back, okay?
It's raining at your home? Leroy,
Do I?
it's raining?
It apparently is raining pretty good because the doorbell camera went off with a lightning.
Okay.
The light flashed and the doorbell camera went off. That's actually kind of neat. That's the first time I've seen that.
Everybody checking their radar or what?
I'm doing that, yeah.
I have a weather gauge outside. It's a piece of rope stapled to a piece of wood. And it says, if it's wet, it probably has been raining.
Okay.
If the rope is moving, it's windy.
This is wireless too.
Yeah, also.
My grandmother actually had a board out on her porch that said stuff like that.
Yeah.
Yeah. It was her weather thing. Yeah.
It's shiny. It's wet.
Did you get the other one from Kendi?
Yeah,
It looked like it just big list of stuff, but I didn't get through all of it.
appreciate it. Thank you.
Somewhere, either there or whatever.
Well, I can use this to interface to the Opto board. That'll be easy.
Easy enough.
Yeah, I'll try to limit it to 16.
This is the weather in Norway.
I'd swear I
No.
had a little red Opto
Middletown.
22 on my desk somewhere. And I'm like, daggone, where'd it go?
This is now.
Yeah, it's right over top of the house. So. If your timeline's accurate, it's right there.
Now will be at the end, right?
It's interesting. It's dry in Milford right now.
This is now.
Yeah, don't go north.
Yeah, it was raining a little when I came down, but it was just kind of sprinkling. It was enough to be annoying.
Five PM, 5:30, 6, 6:20, 6:35. In Hamilton is now the rain.
Yeah. So that's going on way north of me here in, well, there in Milford.
The weather in Hamilton is bad a lot. It's just kind of Hamilton.
It's Hamilton. That happens.
This is Monroe.
Well, it's really overcast in Milford, but it is not raining.
Excello? Is this an Excello and a South Excello? I did not know that.
This is now.
The people in South Excel can't be left out. And combine Acelo and whatever with Monroe and be done with it.
Rabbit robots. Is
North Excello. Yeah, you're looking for rabbit. Up a little bit, just a little bit.
everything is right.
It looked like that storm was moving pretty fast, so. That's close to where we are.
I wish there was a
The
setting
library.
in Chrome for a default of block notifications. I don't want every site to pop up and ask me, because someday I might accidentally hit allow.
Oh, for,
Yeah,
yeah.
I don't want anybody's notifications.
The ones that actually drive me crazy are the ones that do that on the phone. It's like,
Mhm.
I don't want these on my phone. I don't necessarily care about some of them on the computer, but I don't want them on my phone.
You left your drink in the room, and before you go, I wanted to grab those quadcopters, show them to you.
I'm gonna ask. And if you want one, I'll find it on the page and say, yeah, go ahead. You have the right to just always run a little browser somewhere.
The one that, the thing that bugs me lately is it's always telling me that it's using cookies. And I'm like,
Yeah.
yes, I know it's always using cookies.
Everybody uses cookies.
Everybody uses cookies.
Yeah, we can thank the EU for that.
Yeah, I know. I know who we can thank for that one. That's the one that bugs me more than asking me if I
Yeah.
want notifications or whatever. Yes.
Hey, Steve, I got to get going, but I'll put together some stuff for you. Did you want DC or AC? DC, right?
DC, yeah.
DC stuff. Okay.
Cool.
I'll put together some stuff, see what I can find for you. I'm
Okay, cool, thank you.
sure I got that stuff for you. Besides that, love seeing all you guys, everybody.
Bye-bye.
See you later.
Take care.
Here I have the Arduino from Sri Lanka in Asia. This is an Arduino using the microcontroller I am planning to use.
Oh,
Focus.
focus.
Is the only one I found in the internet.
So it's using that 1284 or whatever.
Yeah, this is a T Mega 1284.
That USB-C.
No, USB micro USB. I don't know what happened with my camera.
They do that sometimes. I honestly kind of miss cameras that had the little focus ring on them.
Yeah.
You mean manual focus?
Yeah,
Ooh,
can't find them anymore.
no, here.
Yeah, that's a micro USB. The flat side is towards us.
Yep. What are you gonna do with it?
This is for the emulator I am working on.
Ah,
You say that's from Sri Lanka?
Sri Lanka, yeah. Sri Lanka.
I didn't
Is
realize,
It's the only one I found in the web.
I didn't realize they made anything besides bamboo in Sri Lanka.
Well, there is people there studying electronics.
Well, they're studying it, but the manufacturing
Well,
boards,
they have most of the factories of all the chips in this area of the world. They manufacture a lot of electronics there, all the discrete components, all the.
How much was that?
This one cost $20.
Okay,
I bought two plus shipping 20, so I spent 60 in two of them.
costs $20 to get the two shipped.
Yeah, well, it's the faster way.
that's what I
Oh.
figured it's gonna cost to get a board shipped from the EUs.
I have. Let me show the.
So this means they don't put it on a ship, they put it on a plane.
Yeah, sure. No, yes, this was delivered by DHL.
Ah,
Okay,
Fast.
the fast way.
I found one at a Robot Shop.
Mm,
It looks like it's the same board. 23 bucks. I don't know what they charge for shipping.
what's the robot shop?
It's just an electronics shop. They deal, they sell a lot of robot parts, but they'll sell pretty much any Arduino, any Raspberry Pi, any of that stuff.
I can share the screen now. I found the schematic of the board. You see?
Hmm,
This
That's
is-
the same board. That's the same board I found at Robot Shop.
Okay. Yes, I found the board in RoboShop, but they sell the board and was delivered for this company in Sri Lanka. So I bought it directly for them.
Yeah,
Was faster, you know.
yeah.
But it's the same one.
Robot Shop.
What
They-
is up with the 8 pins that have the wiggly wires?
Wiggly wires.
Right next to the mouse cursor.
Uh,
8 of those wires look like they're fused.
this,
Can you go back to that image that you just had up?
This one?
Yeah,
Uh-huh.
yeah, what,
why are pins 3, 4,
is that
6,
PWM?
7?
That's PWM pins.
so
Right.
there's,
Here,
Okay,
oh,
this is the programming, the 80 mega program interface, you know.
so you're saying those with the wiggle or PWM?
what it looks like.
That's what I'm saying.
So there's 8 PWMs there.
Okay.
Yeah, the squiggles are on the board too.
Yeah, the squiggles are on the
Yeah.
board.
Oh, yeah, it says, that.
You have 4 full ports, 8 bits.
Nope, minimize the picture a little bit so we can see what the key is. There's a key somewhere.
Key, what do you mean key?
the code for what each thing means. It's,
No,
thought-
this,
It
No.
doesn't say, it doesn't say it, does it?
doesn't say, must be on another page.
I asked them for the schematics, but no answer. This is the size in your breadboard. I put it at a scale on a breadboard before it arrives to check if I can connect both sides. And you only have one pin free for your wiring, you know. It's
According
Yeah.
to, according to Robot Shop, there are 8 PWM pins, so I suspect
Yep.
that's what that means.
well here.
Well,
have
if you look over there on the
Two.
left-hand side,
four,
you see the
and-
brown ones there.
Yeah.
It says PWM.
Yeah,
It's kind of cool. I've just never seen that.
so you can look at it
Drawn that
quickly
way.
and see that that's a PWM.
You have 8 analog inputs here.
Yeah,
So you can use the ports as digital or analog as you wish, you know.
it's following a similar pinout to like the Uno. So
Yeah.
yeah.
Is DWE the name of the company?
No, it's the name of the board.
Ah,
The board is Lacduino Dewey, but the
okay.
company is Aptinex. This is the
Mighty
company.
Core.
Mighty Core is the name of the bootloader that you use in Arduino to load your programs. Mighty Core is a board definition that you load in your boards to program this one.
Got a yellow transmit and receive and a green L. Is that hooked up to pin 13? The green LED at the top, it's just labeled as L.
The pin, yeah. Now you don't need to know the pin. Usually Arduino use a definition of LED built-in is a definition. So you use it and it works for any board. This one in particular is connected to the pin. Look here, LED on pin 0 PB0. Here is the LED in this pin. Here.
okay, yeah.
Okay.
It's hooked up. to
But
Pentagon.
this is an operational amplifier, so they have they are sensing the pin to drive the LED. So there is nothing connected to your microcontroller actually, because they are sensing the pin using an operational amplifier. The LED is not connected directly to the pin. Okay.
Okay.
This is done in the Arduino 3, and they did the same here. The other amplifier or comparator is used to change the power from the USB to the B-in battery. So you don't lose those 0.3 volts that used to lose in the old Arduinos. You almost have 5 volts completely because there is a MOSFET switching the power here, and there is an operational amplifier sensing the voltage. So you have almost the full 5 volts in your board instead of 4.7 that are in the nanos or in the old Arduino boards.
Right.
They was using a diode to protect the power, so you always lose some voltage. But they solved the problem with this configuration. Actually, I was studying the operation of the circuit here. I made this diagram. This is the voltage from your battery, and this is the voltage from USB connector. So the comparator switch between the battery to the USB connector using this MOSFET. So you have full 5 volts in your board. And this is how the LED is driving the LED, you see? This is the pin of the Arduino. And this comparator or this operational amplifier is driving the LED. So you have no load in the pin of the microcontroller. And they have LEDs for transmit and receive in your serial communications. This is the board. They have a lot of stuff under the board. This is the 5 volts regulator. When you use a external battery, you use this regulator to produce the 5 volts in your board. This is the serial USB interface chip. This is a fuse of 500 milliamps. Whatever you do with the board, you make a short. This will protect your USB port. But usually the USB ports are protected also. So everything's okay. The reset button. And this is the pinout of the microcontroller. This is in the page of the Mighty Core page. They have this definition of the pins of the board are the same as the ones in this diagram. And that's it. Stop sharing.
Seems to me like I saw somebody else was making a board with a non-standard Arduino board, Arduino. I don't see it now. I can't find it.
I like that the Arduino environment is nice because you can use almost any microcontroller with your same software. Very easy. But actually, I am using the manual of the microcontroller directly because I am controlling all the pins of the, look how I using the microcontroller.
Yeah.
Let me show this. This is my setup in the Arduino. You see setup here, but I am controlling directly all the ports, all the pins in the ports.
What are you trying to show us?
Look,
I see a bunch of your files.
you see this? I am using a direct control of all the registers of the microcontroller to program the timers, to program the ports.
I don't think we're seeing what you think we're seeing.
Okay. What are you seeing? Stop sharing. Then share again. Share.
Just look like a bunch of your
Yeah.
files.
Okay, here, you see?
Yep.
Okay.
Yep.
There you
This
go.
is this is the setup. You see how
Okay.
I control directly the ports of the register.
Yep.
Okay, timers and everything is made directly. So I am using the microcontroller manual to work with the microcontroller and use Arduino code for simple tasks like this is provisional. For example, I want to turn on and off a signal. I can use the Arduino code, but this code is very large to do this. They use like 20 instructions. I can do this with a single one using this technique of driving directly to the ports. So because I am simulating a real microcontroller with another, I need speed. So I try to use directly the registers of the microcontroller as much as possible.
I tried to play with registers one day and confused myself.
I have all the time. I have in PDF the microcontroller data sheet and the CIDA80 data sheet because I am simulating the CIDA80. So I need to check all the time both things to try to figure out how to simulate the behavior of the CIDA80. It's fun. I have a lot of fun with that.
People have different definitions of fun. Have you noticed that?
Well, it's like you like Sudokus.
Yeah.
This is like a Sudoku, but a little
It's
bit.
like a puzzle.
Yeah, exactly.
Number 14.
I think, okay, how can I do this inside the microcontroller? And just go for it.
Have you played number 14? Have you played number 14, Vicente?
What's that?
I'll show
I
you.
feel like I'm about to be recorded.
14.
Let's see here. Make that number using only those numbers one time.
Wow.
This one's one of the easier ones.
Wow, interesting. What's the name of that?
Number
14.
14.
Okay, I will try that. Interesting.
We have digressed.
We have.
You only have those numbers to work with, right?
You only have those numbers to work with. And the idea is to actually do it in as few steps as possible. This one I can only figure out all 5 steps.
Fast. Yeah, you
So
saw
that
80, 72.
That one was one of the easier ones. Number 14.
NBR.
nmbr14.com.
I think I'm gonna.
I play it. It resets every night. It's one game a night.
Right.
It resets every night. Some of them are really, really hard. Some of them are like that where you just go, oh, that's the answer. Keeps your math skills sharp. Surprised you haven't seen me tweet all my number 14s there, Mr. Vicente. You don't pay much attention to Twitter, do you?
Yeah, you know,
No.
I had you. I am very irregular in the Twitter. You know, I see it twice a week or so.
Only when
Lately.
somebody talks to you.
Sometimes I want to post stuff, and I am very frequently at it. But now lately I am just working in my
Yeah.
stuff. And
You're too busy working on important stuff. You don't want to play on Twitter. I think Steve's going to get into it.
already you were at the movie Top Gun, the last one. You saw it?
Have not seen it.
everyone is saying that is very good, you know? Maybe we need to check.
I don't know, that one really, I don't know. I never was a big Top Gun fan in the first time around. So maybe that's why I didn't jump on it. I probably see it when it hits home video or something. though.
It wasn't bad. We saw it. It was pretty good.
When did the original come out?
90s.
94, I think.
Yeah, that's probably about right.
Came out just before Paramount bought Kings Island.
Yeah.
Because they wanted to make a Waterworld ride and a Top Gun ride.
They did
And
make a
they
Top
did,
Gun,
they
yeah.
did make Top Gun. I was in the front car of that the first time it carried people.
If you overlook the main pieces of the movie, you're fine. Just one.
Isn't the main thesis of the movie join the Navy?
No, the main, well, they had Navy guys actually there. They had to recruit a guy and a couple of squids for running around. And they wanted to get there before the unit went online, what is it? The enrichment thing comes online. Well, it takes years after the enrichment machine starts for it to have anything.
$5,000 for that, huh?
Yeah. Do you fit inside this?
There's a review of that in the meeting notes, if anybody cares.
Yeah.
There's a review of that.
I was checking.
It looks very small.
Yeah,
I'd drive that to work. Nowhere else.
Room for four, technically.
Technically,
Yeah.
You kind of drive like this.
Room for four if everybody is a midget.
Chinese joke.
What? What happened?
Oh. So how much would it cost to have it shipped over here?
28,000.
Yeah, that sounds about right. I could break into the savings right now and buy that sucker, but I don't think I could pay to have it shipped.
I'm curious what the range.
There's a review here.
it's made for the city.
Yeah, but it,
25, 30 miles.
I mean, it'd be all right commuting back and forth to work,
Yeah, technically.
technically.
I'm 6 miles from work on the highway, 5 on back roads, but that back road is like this. Teal Town Road. I don't know if you're familiar.
If
I don't
I mean, technically, Patty is trying to get transferred to Springboro, so she would be within 2 miles
That'd be nice.
of work. Right now, we're 15 miles. If there was a 30-mile range, it could be done, but it would need to be charged all
Would
the
work for
time.
the first year.
I would have to get home immediately and charge it. So I could go and pick her up from work.
they don't have charging stations at that Safeway?
We have 2 charging stations that I know of, and both of them are Tesla stations.
We'll get a Tesla instead.
Yeah, that's probably not gonna happen. Pretty much for the same reason I probably couldn't have that shipped. Wonder if it would actually meet import standards in the first place.
Where are you gonna get 9-inch tires?
It looks like everyone's going to the 12 megapixel surveillance cameras now.
Yeah.
Eight's out,
You-
12's in.
you know, that's because you've upgraded all your cameras to
Yeah.
8, right?
Well, I'm picking up the 4s everywhere. The 4s are giving them away. I'm jumping on them.
So that's what happens when you decide to upgrade to something, they're going to decide, oh no, that's not what we're doing anymore. We're doing this. Oh, it's 6:57. Nobody had a timer. I gotta shut down.
Okay, next week,
I'll see you guys later. See you next week.
take care.
Bye.